so much for having me. I really enjoyed Martin's talk previous to this, and thanks to him for kind of teeing me up for this. I will say to the people watching, technically asking, can I have a license is a question. So feel free to ask that question in the chat. So just to kind of give you a little bit of background about this particular talk, a few months ago, I was looking to write a blog post, and I have about 5+ years of experience with Entity Framework 6, and I thought a lot of that knowledge was going to transfer over into Entity Framework Core. To my surprise, that didn't really happen. There's some things that carried over, but as I kind of explored Entity Framework Core, I started to find out that while it still maintains the Entity Framework name, a lot has changed with Entity Framework Core, and I would argue for the better. So if you have a lot of experience with Entity Framework 6, know that you will be able to use Entity Framework Core, but it's probably good to go into Entity Framework Core with kind of a different open mindset. So keep that in mind, and a lot of the slides you'll see here kind of reflect those discoveries that I found kind of going through Entity Framework Core. So just to get started, my name is Khalid Abuhakmeh. You can find at Abuhakmeh. It's kind of a Twitter joke, but yeah, it's my last name. I consider myself an ASP.NET and .NET professional. I've been kind of doing .NET for 15 years, so time flies, I guess, when you're having fun. Currently, I'm a .NET developer advocate with Martin and some of the other .NET advocates over at JetBrains. We recently released a blog post to introduce ourselves, so head over to the blog at JetBrains and you can read all about us. Currently, I consider myself a technical writer, so I write a lot about .NET and I do a lot of demos. You can actually find a lot of my content at abuhakmeh.com. I like to create memes, and I also Photoshop Martin in a lot of weird places and situations. So look on my Twitter for those things. But that's kind of generally who I am and what I do. So before we kind of get into the Entity Framework core pitfalls that I've kind of laid out here in this talk, it's always important to listen to what someone is saying, but also verify for yourself. So from the original Entity Framework Core v1 to where we are today with Entity Framework Core 5, a lot has changed in the internals of Entity Framework Core and how it generates SQL. So some of this advice will be valuable, and it's focused on Entity Framework Core 5. But it can definitely change based on your situation, database engines that you pick, and such and such. So use the advice that I give you in this talk kind of as a starting point, and just test it and verify within your own code bases. So yeah. So I've kind of been talking a lot about Entity Framework and Entity Framework Core, but there's probably some of you out there that maybe don't know what I'm talking about. Entity Framework Core is an object relational mapper. Whenever you're dealing with databases, there's normally this thing called an impedance mismatch. Objects in C#, and then you have tables and indices and all the pieces that normally go into a database. And sometimes those things don't kind of match one-to-one. An ORM, or object relational mapper, kind of helps you access a database in a way that's very C#-like, kind of fits within the C# idioms. That's normally a good thing, but you'll see some of these pitfalls kind of fall into the fact that sometimes maybe we're not thinking about that we're dealing with a database. So EF Core is just an object relational mapper. There are other ones in the ecosystem, but we'll focus on Entity Framework Core today. So one of the first problems that I found, even going through Entity Framework Core documentation, is everybody wants you to install the .NET CLI tools globally, meaning they're available anytime you open up a command line. You can start a .NET Entity Framework Core project or add the design tools to any C# project on your computer. That's kind of all in good, but it actually leads to a lot of problems, especially with the current iterations of .NET. I'm sure a lot of folks are starting to realize like .NET is moving very fast, and there are a lot of versions being bumped. If you're in a team that manages a lot of solutions or projects, it can definitely be problematic if you're upgrading for one project but need to stay on a particular version for another project. So the first thing I would tell anybody getting into Entity Framework Core, install your tools locally. And I'll show you how to do that. But another reason this kind of happened was as .NET Core was evolving, there was really no concept of installing tools locally to a project. And that's kind of evolved as .NET Core version numbers have gotten higher. So the first thing you want to do is once you start a C# project is open up a command line tool. And from the solution directory, you just want to type .NET new tool manifest. What that will actually do is create a .config folder and create this JSON file called .NET tools.json. In here, you're going to have all the locally installed tools that you're going to add to your solution. The next step is to say .NET tool install and then install the .NET EF tools. So if you were to go to the Microsoft Docs documentation, if you go through their installation guide, you'll see that there's a -- global flag. Just don't do that. And if everything works out okay, you'll have the .NET Entity Framework CLI tools installed specifically for your project, and the version number will match when that project is pulled down. The other advantage for me is that once I create demos, and as an advocate, when I create demos, people can pull these projects down and they're completely self-contained, which is always a positive for me. I'd hate for someone to download a demo or a project and not be able to run it. So once you have the tools installed, you're obviously going to want to pick a database. And I think this is the #1 problem people run into when they start thinking about testing and running their production application. I know when I came to use Entity Framework 6, there wasn't really a lot of choices in terms of database providers. It was SQL Server for the most part. When I did testing locally, I would use something like LocalDB. And that worked for the most part. And then we would deploy to something like SQL Azure. Being both at LocalDB and SQL Azure are variants of SQL Server, testing and running in production were pretty similar. But in today's environment of cross-platform and .NET Core being cross-platform, you have database engines that could range from SQLite, Oracle, MySQL, Postgres is really popular right now in .NET, and SQL Server. So some of the samples that I've seen that are a big no-no for me is people write tests against something like SQLite or an in-memory version of a database, which Entity Framework Core ships with. And people will write unit tests against those, which are different database engines, deployed to production, and then there's just bugs galore everywhere, right? So keep in mind that you want to actually test against the same databases you're writing code against. And in today's landscape of technologies, that's really easy. Just adopting something like Docker into your test framework can go a long way to helping you keep the same database engine regardless of environment. So this one is kind of a political problem. And I think it stems from how companies are normally structured. So if you work in a team that has database administrators and developers, and they're kind of treated as separate teams, you might have database administrators kind of dictate the naming convention of your databases. And while Entity Framework Core has the mechanisms to support non-conventional naming, it's really a headache. So buy your database administrator a box of chocolates or a six-pack of beer and try to convince them that what they really want is just to adopt the Entity Framework Core naming convention. Things I've seen DBAs use in the past, snake case, which is underscores, kebab case, and then prefixes. So those aren't normally things that you want to take care of in Entity Framework Core, and they can cause kind of like problems when you're starting out to use Entity Framework Core. So let's say you're starting with an existing database. Your first instinct might actually be to handcraft every single model or every single table that exists in your database. What people don't realize is Entity Framework Core actually ships with reverse engineering in the box as part of the CLI tools. So if you have an existing database, something like Northwind, you can just run a command like this. So .NET EF, DBCONTEXT, give it a connection string, and then you also want to give it the Entity Framework Core database provider. In this case, I'm using SQL Server, but I think it also works with things like MySQL and Postgres as well. So depending on your database engine, and if you have an existing database, this might be something you want to consider. So this one, this one is a little bit controversial. I know this kind of divides the .NET community, and I kind of sit on one side of the argument. But please, I'm begging you, please don't wrap your DB context in an interface, in an iRepository generic type interface. The DB context is already considered a unit of work, and it has an expressive LINQ interface. And by wrapping it inside of a repository, you can actually introduce a lot of performance issues into your applications. It also makes it very difficult to rationalize about the relationships between each model. So causing you to actually introduce a lot of bugs in your code. I've had to deal with a lot of these code bases using Entity Framework Core and wrapping them in a repository. And yeah, if you want to be a hero, you can find these code bases and actually get a lot of performance back just by removing a lot of these interfaces. Okay, this is another kind of misconception with Entity Framework when folks start to get started with it. is they see these classes in C# code and they treat them just like they are C# objects. And while they technically are C# objects, I like to think of them as kind of representing my database model or my database schema. So in a sense, you want to keep them as similar to your database as possible and avoid doing things like adding helper methods or properties, because in this example here, I've added a property called average rating. What it does is it looks at that list of ratings, that collection of ratings, and in C#, that would work because those that ratings data would actually be in memory, and you would actually get the average every single time. If this is an entity framework core, you would have to load those ratings from the database. Seeing that it's a different table, that could be thousands, millions. So that average rating property doesn't make a lot of sense. But when you start thinking about these entities more as representations of your table, things start to make more sense, and you kind of keep yourself out of trouble. Another issue that I've seen in a lot of entity framework core and entity framework code bases, folks accidentally querying all the data out of their database. I know as developers, we start on our machines, we design tables. Maybe we'll put 10 to 20 records in the table and then call toList async, and then everything works out great locally. And then you start pushing code to production, and before you know it, there's 100,000 records in one table, and your app is slow, everyone's complaining, what's going on, what happened? And it's because you just didn't test with production-like data, and you accidentally enumerated the entire data set into memory. So if you're finding method calls to toList async or toDictionary in your code base, and you forget to do something, or you forget to call skip or take, you probably have a performance issue waiting to happen in your code base. And I've kind of seen this a lot. And again, this probably happens early on in development when folks maybe aren't dealing with production size data sets. So this is one of the misconceptions that I had coming into this talk / blog post, is Entity Framework 6 comes with lazy loading pre-enabled. What that means is, in this example, the production is a related entity to a rating. And in Entity Framework 6, when you execute that C# code, another SQL statement and a connection to the database would get triggered, pull that data back, and then continue on with your C# code execution. That actually is not enabled by default in Entity Framework Core. You can enable it. It's a separate package entirely, and you can configure it in the options. But for the sake of your own safety and the safety of your team members, I'm just not going to show you how to enable it. If you were to go into an Entity Framework Core project and see lazy loading enabled, really question why it's enabled, because this lazy loading can be a severe problem, and it's not really immediately evident where the performance problems are happening. Like this code example right here, if you were to show that to 10 developers, 9 out of the 10 developers wouldn't realize that that call to production is actually making a secondary SQL call. So don't enable lazy loading, in short. So you know how previously I talked about people treating entity framework classes as if they were C# objects? And you really should think about them as representations of your data model or your database. So entities will map to your tables. And once you start thinking like that, you'll realize you want to treat those classes as if you could be selective about the data you want to bring back. So instead of just, in this case, I have a DB set of characters, which is a table in my database. And I'm filtering on the actor names. In this case, we want to find out what actors play themselves in movies. But we want to project into a new object just their name and just the actor name. Obviously, in this case, they'll be the same, but we're going to only pull back 2 pieces of data rather than if that characters table had 100 columns. If we didn't do that style of projection, we'd be pulling back 100 columns worth of data that we're ultimately going to throw away anyways. So not using projections is another big problem that I've seen in code bases because it's just wasteful when you think about network IO and the data you bring back. So another thing that I've seen that can kind of be detrimental to performance and you should really try to avoid. I'll probably go back on this a little bit in the next slide, but for the most part, if you have related data and you know you're going to need it, you want to use the include extension method. What that does is it preemptively fetches related data by generating a SQL join. This is good because you'll make one network call and you'll retrieve all the data. And when you're dealing with databases, especially an application, your basic business application where you have your front end and your database, making those database calls over the network are going to be your most expensive operations for your users. And your users will notice over time as you add more SQL calls. So you kind of want to limit that and keep that to a minimum. So in this example, I'm just loading the characters that would also be in this movie. And you can see here, we're actually where the SQL join happens. So I kind of said in the previous slide that you should not run multiple queries, but another problem that I've seen is including too much data by using the include keyword. This is a place where you're probably going to have to use some thought and some care about the specific style of data that you're querying. And sometimes not running multiple queries can actually be detrimental to your performance as well. In this example, I'm running that same query from the previous one. And while it's performant, you can see in the highlighted text on the left in the yellow box, that's all duplicate data. It's not bad when you join maybe 2 tables, but as you start to add more includes in nested tables, in this case, characters are played by actors. Actors might have agents. And if that relationship is really deep, you could get into a situation known as a Cartesian explosion. where most of the data on the left is actually starting to repeat. And as you bring that data back over from the database into your application's memory, it can be really, really expensive. What you might actually want to do is just query productions and characters and actors, maybe as 3 different SQL queries. Luckily for us, Entity Framework has this new extension known as split query, which is really, really nice. So in this case, I'm calling movies, but I also want to include characters and actors. What Entity Framework Core will do is it'll realize that I want those 3 things, and it'll execute those queries and pull back that data and then kind of marry them back together. So it's kind of weird in terms of the output, though. It actually generates the LINQ queries being executed in split query mode. So it might be a little weird if you're trying to debug an issue. But keep that in mind when you're thinking about including data. Sometimes it actually might be more performant to execute them separately based on the amount of data that you return back. This is kind of another big problem that I've seen. I've done this myself. You kind of get excited about modeling your data. You're not necessarily thinking about your data size. You haven't necessarily figured out how your application is going to go together. And before you know it, you're in production. You have, millions of records and you're running your queries. And then you start realize your application is getting slower. You've probably forgot to add indices on specific columns that you're using for filtering. Things like date columns are pretty common, tag and enumeration columns. So Entity Framework has indexing code or indexing attributes. So remember to use them to make sure that your application stays performant. This is kind of another sin that I've kind of committed when using Entity Framework, and everybody should really think about this one in particular. Entity Framework and Entity Framework Core will generate the SQL from the LINQ statements that you write. If you're using things like projections, you might be getting the data back that you want, and it maps directly into your objects, but that SQL will actually not be the best SQL executing against your database. So I know in the past I've gotten a little excited about writing a complex LINQ statement that I thought worked and was good, but then I deploy that to production and it maybe doesn't work the best way. So if you write LINQ, you should always kind of be cautious and actually look at the SQL that it's generating if your LINQ statement has any amount of complexity. So look at the SQL. Entity Framework Core actually makes that really easy now. There's an extension method where you can get the query string right from your LINQ statements, which is really awesome. Look at the results set. And I don't mean your C# objects, but look at the results that are actually returned in some kind of SQL tool. I know in JetBrains Writer, it's really easy to just go to that database tab, copy that SQL, and run that and see what the actual result set looks like, because that's what's going to get returned and processed by Entity Framework Core. Additionally, too, think about how your LINQ statements are going to evolve as your application changes. And this is probably where you might switch from running everything over one database call to maybe splitting it up into multiple calls. So I talked about not trusting your first LINQ queries, but maybe sometimes you don't want to use LINQ queries at all. C# expressions are really, really expensive. Entity Framework and Entity Framework Core will cache LINQ expressions, but they're still really expensive, and anyone who's used Entity Framework Core will always notice that the first query is always slower than every subsequent query. For small applications, that might be okay. For niche business applications, that might be okay. But as your application scales, you actually might want to consider baking your SQL statements and just executing them without any LINQ expressions. 10 to 100 milliseconds might not seem like a lot, but you multiply that over hundreds of thousands of calls, and you're going to start to see a gain there. So while LINQ is a good developer experience, ultimately it might not provide the best production experience as your application grows and scales. So keep this one in mind. Luckily for us, Entity Framework Core actually has some really good extension methods that allow us to pass in strings. In Writer, you can actually inject the database connection and the SQL syntax directly into those strings. So you can do amazing things like write a SQL statement and execute it right from your C# code against an existing database instance that you're running against. So always think about this stuff. There are some limitations to it, though. I found right now that you need to run SQL that returns the full model that you're deserializing into, which is kind of limiting. So keep those limitations in mind when you're using raw SQL. So I talked about raw SQL. There's also this extension method from SQL interpolated, which allows you to take parameters in. It's really nice, but it's also really easy to introduce a SQL injection attack. So in the first example, we're passing in an interpolated string, and we'll pass in the ID, and that will actually be safe. In the second example, that's not safe because the string interpolation actually happens in C# code, and then we pass in our SQL statement. So imagine if that ID was to come from a user, they could, run a SQL injection attack. So for the most part, don't do this, right? You don't want to do this because this is bad. Another performance implication that I kind of see people forget about when using Entity Framework Core is object tracking. This is one of the core features of any object relational mapper. You pull objects out of your database, you modify the C# objects, and then you tell your DBCONTEXT or your ORM to persist those changes back to the database. Well, that's good when you have a read-write scenario or you're mutating state in a database. But most applications, and I'm pulling a number out of thin air, but 90% of situations within an application are usually reads. And those reads are, I pull the data from the database that the user requested, and then I serialize it either over some kind of API or render it out to some kind of UI. And nowhere in that scenario did we ever change the data. So opting into object tracking can be really, really expensive and not something you want all the time. So be sure to look at whether you're modifying objects. If you're not, apply the as-no tracking method to your query. This will actually add a lot of performance to your query because we're no longer tracking objects and whether we're going to change properties or not. And we're not asking Entity Framework Core to do that. There is a downside to that, though. If you're not tracking objects, if there are duplicate rows by identifier, those objects will actually be stored in duplicate in memory. So there's a memory implication there. Entity Framework Core actually introduces a new method, as no tracking with identity resolution. And what that does is it looks at the identifier of each row and will replace that reference in memory with the most recent row from our executed SQL. So keep all three of these scenarios in mind when you're kind of querying data through Entity Framework Core, and see which one kind of works out best for you. This is a problem that I've seen happen in potentially mobile applications if they decide to use Entity Framework Core. I know the mobile community doesn't like using Entity Framework Core. Most of the time they end up using key value stores. If you're using something like WinForms or WPF, this could be a common problem. But you don't want any long-lived DB context. In the previous slide, we talked about object tracking. All those objects will stay with the DB context. So if you have a long-lived DB context, you may actually introduce a memory leak. You might be dealing with stale data. For the most part, you want to create and instantiate a DB context, execute your query, and then dispose of the DB context as quickly as you created it. In ASP.NET Core, this is usually pretty easy because dependency injection is now a big part of ASP.NET Core, and you get transient DB context injected into your MVC actions or your endpoints. So it's normally not a problem in ASP.NET Core, but something to be mindful of if you develop in any other type of medium in the .NET ecosystem. This is another big problem. I'm guilty of this one myself, but again, you might not actually be dealing with production style data sets. So you write a query, you get the data back, it does what you want it to do, and you're happy, you push it up to production, and then it's a complete trash fire. So make sure that you're constantly measuring query performance. This is a screenshot right from JetBrains Writer. You can copy your SQL statements from Entity Framework Core and execute an execution plan. And you can kind of see, even in this example, you can see indices are getting hit by the query and where we're doing a full table scan. So always measure your queries. A big part of using Entity Framework, though, is kind of an evolving model. So you always want to think about how your database is going to change over time. The mechanism that ships with Entity Framework Core is Entity Framework Core migrations. In Entity Framework 6, they were terrible. I don't think anybody used them. Entity Framework Core works a lot better. It's still not perfect, but it's definitely well thought out in terms of a team environment. But make sure you think about how your database models are going to evolve. You also want to think about when and where you apply your migrations. I know a lot of people will maybe do it when the app starts up. It works, but depending on how your data is growing, it might not actually be a good idea to do it when your application starts. Like a story, one of the stories that I have from accidentally doing that, running my migrations when the application starts up, is if you try to apply an index over millions of rows, that's normally a process that's going to take minutes to execute. But in ASP.NET, you might have a request timeout of maybe 60 seconds, maybe 30 seconds. So if you were to deploy your application to production, you've essentially deadlocked your application by doing that. So be mindful about your migrations, realize what they're going to do. And the recommendation here is probably to run them out of band or as part of some kind of continuous integration process. Another thing that I've seen, I'm kind of not sure why it's still a part of Entity Framework Core, but table per type inheritance is possible. So we talked about how C# objects, how you can define C# objects to kind of mimic your table structure. Entity Framework Core allows you to actually use object inheritance that maps to your database. One of those approaches is a table per type. And please don't, you might want to use this because it feels good. Like if you're designing your database, all the data is in separate tables. It looks nice in a diagram tool. But it's a complete nightmare when you want to query like things. So in this example, I have a base table of course. We have online course and on-site course as derivatives of course. If we wanted to get all the courses out of our database and use that polymorphic behavior that Entity Framework Core provides, we would have to join all these tables together. And the issue with that is right now we only have 3 tables involved. But if we were to add 4 more types of courses to our system, then that's a lot of tables being joined, and it can be really, really expensive. So the only time you want to use a table per type is you have an inheritance model, but each derivative type is not actually related to the other types of things, and you'll never query them from their base type. In my experience, I've never seen that happen, but you could be the exception. But for the most part, I would not ever recommend you use table per type. It's a performance disaster waiting to happen. What you actually want to use is table per hierarchy. So what this does is takes all like things, puts them into a singular table, and then differentiates each of those types by a discriminator column. The nice thing about this is you get a lot of performance benefits because you're only ever hitting one table, but there's multiple entity types within the same table. So use this approach. If you're performance minded, don't use the other approach. But if you do use that approach, you'll get some really pretty diagrams and some upset users. Another thing that's kind of a pitfall that I've seen, which I didn't learn this until I started putting this talk together. And it's obvious now that I think about it, knowing how Entity Framework works. But each expression, each LINQ expression is actually cached by Entity Framework. They do that for performance benefits. But if you're actually to hard code constants into your expressions, like in the 2 top LINQ queries, Entity Framework Core will actually see those as 2 different expression trees. And you actually won't get the performance benefits of Entity Framework caching. In the 2 bottom examples, you can see it's the same exact expression, and the constants actually defined outside of our LINQ statement. So we actually get that cache benefit that's built into Entity Framework Core. So the moral of this story, don't hard code your constants into your LINQ queries. It'll actually be detrimental to performance. And finally, this one's maybe this one's kind of the most controversial pitfall, but Entity Framework is a complex piece of machinery, and it comes with a lot of benefits, but it also comes with a lot of downsides. So if you're writing something that's maybe hitting one table, Entity Framework Core might not actually be the best option for you. If you're starting to scale and you're realizing that Entity Framework Core's overhead is starting to compound based on your scale, maybe Entity Framework Core is not the right tool for you. I will say Entity Framework Core is a lot better at generating SQL than its predecessor, Entity Framework 6. And the team continues to make it better. So for me, Entity Framework Core is really good for a large portion of people to start with. And especially with like the SQL, raw SQL components of Entity Framework Core, I think there's an opportunity to optimize around some of the overhead of Entity Framework Core. So I've hit a lot of the points that are in a particular blog post that I wrote for JetBrains, titled Entity Framework Core 5, Pitfalls to Avoid and Ideas to Try. I have the QR code here, so if you pull out your phone and take a picture of this, you'll actually be able to go directly to that blog post. There are a couple points in the blog post that I didn't mention in this talk. So if you're interested in seeing those, please head over to this blog. We also regularly have webinars on different topics as well on our YouTube channel, so check those out. And you can, if you have any questions, please feel free to ask them in chat or follow me on Twitter, and I'll be glad to answer any questions there. So other than that, thanks for taking this time to listen to this, and hopefully you learned something. Now the awkwardness happens. Awkward silence.
I'll help you out there as well if you want.
Yeah, sure.
So while we wait for incoming questions, I actually have one for you.
Yeah, sure.
You mentioned a lot of cases about performance optimizations and so on. There's also migrations. Now, I know from doing a lot of Azure that in our databases, there was sometimes this thing enabled that does auto-tuning. So essentially watches query plans and automatically sort of optimizes indexes and things like that. Do you have any recommendation on how to feed those back into your migrations so that the next time you deploy or the next time you upgrade your database based on the migration, everything keeps working, first of all, but second, that all of those things come along?
Yeah, there's definitely a couple strategies that I've kind of employed in the past. Speaking specifically about the SQL Azure tuning stuff, sometimes teams might want to actually treat indices like database maintenance separate from structural schematic changes, and have a database administrator or a DevOps team focus on fine tuning. So in a sense, in your application code, those indices just don't make it into source control because it's just manually tuned by individuals. Additionally, too, you can take those recommendations from SQL Azure and codify them. You can actually create empty migrations using Entity Framework Core's CLI tooling. So you can just create an empty migration and then copy that maybe a new index into your code and then execute them that way. So that's also an option. So hopefully I answered your question.
Thank you.
Yeah. Yeah, performance is probably the number one concern I know people have about using an ORM like Entity Framework. I know a lot of people are fans of tools like Dapper or NPOCO. I'm trying to think of other micro ORMs out there, but those are definitely cool, but they also lack some of the niceties of something like Entity Framework Core. So, all right, I see one from, how would you pronounce that name, Martin?
That would be Jeroen.
Jeroen. Okay, you have shown a slide about the DB context injected into repository. What exactly is the downside there? What is the alternative? That's a good question. I think it comes down to this idea, for me at least, when people start building out with repositories, they actually create them around individual entities. So in my case, I have a movie DB context, and you have things like productions and actors. And a database is very related. So when you want to create a query to pull back movies, in some cases, you might want to pull back movies and actors in a single query. But if you were to put movies and actors in two separate different repositories, you're almost immediately forced to make two SQL calls that are less than optimal. So right off the bat, you're in a situation where you're running less than optimal code, and you've introduced a performance issue before you've actually even built your application. So hopefully that answers that question.